So, my dear friends, first of all, very welcome to all of you to Yourpedia. And as you know, in case of if we talk about the BEL, then the most number of questions, or you can say the various number of questions going to ask from the production engineering, obviously, along with industrial engineering. So, these two subject is very important. And what is happening? Generally, students think that production is a tough, right? General student, if you ask any student, which one is the tougher subject of mechanical? So most of the student is going to be answer, so it will be the production, because generally a student thinks that production is the subject that you have to buy heart. But usually, if you see in my over the YouTube, any times I used to say engineering is not for the by heart. You have to know the cause. If you know the cause of anything, now my dear friends, it will be not a tougher. But if you don't know the cause, just you are going to buy heart, then you will find okay, it look like that subject is tougher. And that's why, my dear friends, in whole production engineering, what will be our target? Our target will be to clear the basic things. And what is the cause? Due to this particular thing is going to be happened. And once if you know the cause, I am damn sure you will never forget. That is the first thing. Second thing is what, my dear friends? Generally, in the production engineering, what is happening? A student is not able to visualize the things, right? Suppose if you talk about the casting, if you talk about the welding, if you talk about the metal cutting, anything, if you are not visualized, na, then again you are getting difficult, right? So our target will be in the production engineering to discuss all the things along with video. So that, because usually I used to say, just I want to tell one story, and another I am going to be watch your movie. The which one you can remember for a longer time? Obviously, we can say movie. Why? Because it is a visual representation, and it is a very basic things for our mind. If anything you see the visual representation, it will be remembered for a longer time. That's why second thing what I am going to do in the production engineering, whatever I will taught you, first I will play the video, you then I will elaborate all the things, then we'll discuss the concept, so that uh, you can gain the maximum marks from the production. And today is the first class, and I want to be damn sure at the last of the production you will be able to recall, okay, most of the thing I have remembered, most of the thing I have understand. It is not a difficult. This is second thing. And third thing that I want to discuss before starting the session, your continuity. What is happening? Today is the first class. Most of the student I am going to be see there attending the live. As time passes, I don't know what is happening in all the batch. Students suddenly, okay, I will watch the lecture recording format because I have recording, and that time never comes. So your first priority should be, I have to attend the class live. You have a 3 month, you have given the fees, so just focus, leave all the work. Your first priority should be, I have to attend the live class. Once you have that mentality, now my dear friends, okay, I will watch the recording. And that is, I think, one of the drawback for the online. What a student think, okay, I have recording, I will watch later. And from your experience, even I have lot of experience that things, at the last student have all the recording, they are not visited over 40% of the recording. That mostly I have felt in the online. So take a oath, I have to do every day live class. Another advantage of live is what? Suppose you are getting any doubt, you have any problem, directly we can ask. But in the recording, sometimes you fall on that things, right? So that all things you have to be keep in mind, my dear friends. Okay, and okay, fourth thing that I want to tell, I will start from the very basics, because there are all types of students. Someone is fresher, someone have some experience. So I will start from the very basics by assuming you don't know anything, so that any student is there, they will not find difficulties. So that is the fourth thing you have to be keep in mind. And most important, you have to be attend the class daily live. Try to live, unless and until not any much more urgency. Before that, try to attend the live class, right? Now, my dear friends, if you talk about production engineering, we have seen in 2024 12 question, after that 21 question. So number of question is going to be asked, much more question is going to ask from the production. Expected, you can understand, 2025 23 question, expect that year also. So in this, I am going to check your comment. From the last exam, what suggestion? Yes, I will give in the exam session. Don't worry. What type of question, what is going to be happen, everything I will discuss. Okay, so don't worry. So my dear friends, Today I am going to be start what? Welding, right? Today I am going to be start welding. Okay, one more thing, my dear friends, I want to tell you. The syllabus is much more, right? Obviously. But the thing is that the question is going to be everything asked from some specific portion. So rather than studying all the various things, the thing is that the question read that particular concept or topic from which question is usually asked, so that it will not become a burden, right? So that will be our priority to take that concept in very detail which is required. Otherwise I will try to cover all the things in detail, right? But the concept which is more important I will cover in the very details, right? Sir, skin not clearly visible, is it right? Everyone tell me, skin is totally visible now, my dear friends? Anything is problem is there? Everything is right? Tell me. And in this format, my dear friends, daily I will come with question, there will be answer in between that, and I will share at the end of the class. Every class our target will be 30 to 35 question we will discuss, which will be much more important, and question will find directly from that one, right? So in that way I will share the PDF daily to you. Clear? Human, you can join again if you find any difficulties here. Okay. So, my dear friends, what I have to be discussed here, little bit I want to be tell you there, what topic I have to be discussed in the production. Yes, first I am going to be discuss about the welding, then casting, then metal cutting. After metal cutting, I will discuss machining both conventional as well as non-conventional. After that, I am going to discuss metrology and inspection. Metrology and inspection. Welding, casting, metal cutting, machining, metrology, inspection. Material science I will deal later. If anything is left, I will see. So these 4 or 5 topic is there, which is obviously one topic is left. This is metal forming. This is metal forming, right? So my dear friends, I will discuss all the concept, but our focus will be much more on that topic from where in the last 2024, 2025, everywhere question has been asked. That will be the major focus I will be on that part. Okay. So that is the thing. And last thing again I want to be tell you, you have to be maintain the continuity. So today I am going to start the one of the topic. This is called welding. So what do you mean by welding? So any student can say from the very, first I know about the welding. What is welding, my dear friends? So sir, welding is a fabrication process. What? It is a joining process, right? It is a joining. Which type of joining? Joining process 2 types. Either it will be the temporary or permanent. So welding is a not temporary, it is a permanent. What do you mean by permanent, sir? Permanent means suppose once you have welded and you want to be disengage the joint. So what is happening? If you are going to disengage the joint, what is happening? There will be effect on the parent matter. So this is called what? This is called, you can say, the permanent. What is temporary? Like you are going to make a joint, nut and bolt you can use, but if you disengage the joint, there is no any effect on the parent material or the base material. So it is a what? Which type of process, my dear friends? Permanent joining or fabrication process by using what? By using, either you can use the heat or you can use the pressure or you can use both. So welding is a permanent fabrication process by using heat or pressure or both. That is the simple definition of the welding. If you talk about heat, where heat is going to be used. So in case of arc welding, if you talk about arc welding, I will discuss. If you talk about gas welding, so in this you are going to apply the heat. If you talk about if you talk about another is what? Explosion welding. In explosion welding, pressure is used. If you talk about friction welding, so in the friction welding, both heat as well as, I will discuss all this, don't worry, this is just a little bit introduction. So heat in arc or gas welding, you are going to use heat. In case of explosion welding, you are going to use the pressure. In case of resistance welding, you are going to use both heat as well as pressure. So sir, you have just talked about the arc. First thing we have discussed about the arc welding. So what is arc welding, sir? What is arc welding? First I will discuss their mechanism, then I will come to the question part. Okay, before that I want to ask one question, my dear friends, just to know. One thing is arc and another thing is you might have listened spark. Can anybody can tell me what is difference between arc and spark? That is the question has been asked in interview shared by one of the student. Uh, Sir, NVT is telling, sir, should you need to write down a note? No, you don't have to be write down the note. If I am going to be discussed, I will share all that, first thing. Second thing, I will share the whole welding notes also. But if anything is important point that I am going to discuss, just take a 5 to 7 page or 10 page of notes. If anything important I am going to discuss, that write down. Don't try to write down all the things, because everything I am going to be shared in the written format to you. So don't waste time on that. But yes, if you find anything is much more important, you can write. Otherwise, you don't have to be write, because everything I am going to be shared with you. Even I will share the my offline classroom notes also. So don't worry about that. Okay, so that was my question. Can anybody can tell me what is difference between arc and spark? What you think? So here I am going to discuss about the arc welding. That is the topic that I have to be start today. Arc welding. So sir, first I will see the mechanism how arc welding is work. And meanwhile, you have to be comment. At the last, I will give the answer. What is difference between arc and spark? So first of all, what you have to do for the arc welding, my dear friends, you have one workpiece, right? Suppose this is one of the workpiece that you have. You will have one electrode. What is electrode, sir? What is electrode? Electrode is nothing, my dear friends. Anything which can conduct electricity is called is what, my dear friends? Is called, simply we can say, electrode. Anything which can conduct electricity is called electrode. So simply you have a workpiece, you have electrode. Okay, first step for generating the arc, what you have to do? You have to do the short circuit. So first step in, you have to do the what? Short circuit. Sir, what is short circuit? What is short circuit? In the usually you have seen that it's due to the short circuit the fire takes place, right now, and it is becomes very harmful. So first of all, you have to do the short circuit. What is short circuit? See there. See, my dear friends, what? Suppose this is your workpiece, okay, and this is your electrode. You are making a here a contact. There is a direct contact between the electrode and the workpiece. There is a direct contact. So what is why you are going to do the short circuit? That is the first thing. Short circuit you are going to do. Whenever you are going to do the short circuit, what is happening? At that point, huge amount of heat is generated. Huge amount heat is generated during the short circuit. What is happening? Huge amount of heat is generated. Why, sir? Why need of heat, sir? Why? Because my dear friends, arc is, it is basically flow of ions. What this is? Flow of ions. Arc is what, my dear friends? Flow of ions. Ions could be two types. Either it is positive ions or negative ions. Right. So first of all, you have to do the short circuit. During short circuit, what is happening? Due to the short circuit, there is a lot of heat is generated at the contact point. Due to that heat, now ions is getting in the excited state. So what is happening after short circuit? Now you are going to disengage the this is the workpiece. You have disengaged the joint. Just disengage. Now after that, what is happening? The arc is established. After that, arc is starting. So if any time the question is going to be asked why you are going to do the short circuit, we can say short circuit is done because of that the heat is generated huge amount. Due to that heat, what is happening? Ion get excited and they start moving, and this is called is what? This is called is your simply arc. Now we can say, sir, just you have told one thing, sir. Just you have told one thing. Sir, it is a flow of ions. Ions can be two types, no, sir. It can be two types. It can be positive or it can be negative, right, sir? Yeah, right. So now the question is that, sir, which one will move first? Either both will move first, or first positive ions or negative ions. Then my concept, one thing is come. This is called bonding energy. What? Bonding energy. What is bonding energy, sir? What is bonding energy? Everything is written in the notes. Don't write. Everything is going to written in the notes that I will share. The offline classroom notes, everything is written. So don't worry. Bonding energy is that energy, my dear friends, which required. This is minimum amount of energy required to get excited the ions. आयंस को एक्साइटेड करने के लिए जो मिनिमम अमाउंट की रिक्वायरमेंट है यही कहलाता है बॉन्डिंग एनर्जी. नाउ इफ यू थिंक अबाउट positive ions, then the positive ions have less bonding energy. Positive ions have less bonding energy compared to negative ions. So what is happening, my dear friends? To start that are, first of all, positive ions move. Positive ions move. Suppose here you can see there the workpiece is connected with the positive terminal, electrode connected with the negative terminal. See there. This is your workpiece. This is your workpiece. This is your electrode. This is your less electrode which is connected with the negative terminal. This is connected with the positive terminal. So first of all, which one will move? So positive ions will move. So positive ions means workpiece is connected. So positive ions will move like that, sir. From there, positive ions move like that, sir. That like that, it will move like that, sir. It will move like that, sir. Right. In the negative ions, it will move. Now, what is happening? When the positive ions, this is all are positive ions, right? When these positive ions move, they have some kinetic energy. What is equation of kinetic energy, my dear friends? Kinetic energy is half mv square. Half mv square, right? That is called kinetic energy. So when they are moving, they have kinetic energy half mv square. Once they strike on the electrode, whatever this kinetic energy, this converted into the heat. This converted into what? Heat. And once the heat is going to on that, what is happening? The whatever required potential, whatever required bonding energy for the negative ions, they will get. And after that, what is happening? The negative ions start moving from that one. After that, this negative ions comes on strike on that one. Okay, one more thing, my dear friends, we can say, sir, this is positive ions moving like that. So you know what is happening? Around that there is a air, right? Surrounding is what? Air. So air will, what is going to do? Air will oppose the movement of positive ions. That's why the velocity of positive ions is less. And since electron is moving in gap, so electron is not disturbed. So they have more, or you can say the higher, energy or kinetic energy. Now, my dear friends, tell me one thing. As they will come on heat on that one, again heat is generated. So here we can say, sir, heat is generated at both the end. Here also heat is generated, and here also heat is generated. Now my question is that where more heat is generated? In this case, on the electrode or you can say workpiece, where more heat is generated? Can anybody can tell me? We can say, sir, I know. What is kinetic energy, sir? Kinetic energy is what? Half mv square, right? So particles or ions having more kinetic energy, they will give the more heat. No, anybody can tell me which one have more kinetic energy? So we can say, sir, in case of positive ions, since velocity is lesser, so positive ions have less kinetic energy. So heat generated at the electrode, in that case, when the electrode is connected with the negative terminal, workpiece is connected with the positive terminal, so less heat generated at the electrode, or more heat is generated on the workpiece. So one thing that you have to be keep in mind, the end towards negative ions goes more heat generated, and the end where positive ions goes will less heat generated, because the velocity of the positive ions is less. Sometimes in the class usually student is asked, sir, I know mass of positive ions is more than mass of negative ions. So sir, I think the more kinetic energy should have positive ions. No, my dear friends, kinetic energy is a strong function of velocity rather than mass. You are right. Mass of positive is more than mass of negative. So it should be. But since velocity is squared, so higher velocity electron have, that's why more heat is going to be generated over that one, where negative ions is going to be strike. Okay, clear? Till now everything is clear. So that is the mechanism of the arc welding. That is the mechanism how arc is generated. So sometimes Now suppose if you are not going to do the short circuit, then what is happening? We will not get the arc, because by doing the short circuit, the energy getting high, due to that the ions get in the excited state, and once you disengage the joint, they start moving and arc is get generated. So that is the first thing you have to be. Kindly bonding energy once again. Okay, who one is there? Mr. Sharma. Bonding energy is what? What the bonding energy? Bonding energy is basically, it is the minimum amount of energy required. Listen, bonding energy is the amount of minimum energy required to get excited state of the ions. This is the minimum amount of energy required so that ion can start move. That is called the bonding energy, right? Okay. Now my dear friends, so till now I think everything is clear. I will discuss all the things later. That concept will be used. Now if you talk about polarity, see here, this is three polarity I am going to discuss. Suppose this is the workpiece and this is your electrode. This is your electrode. Electrode is connected with the negative terminal and this is connected with the positive terminal, right? And obviously this is DC power source. This is another case could be like that. Suppose this is the workpiece. Now this is your electrode. This is your electrode and it is connected to the positive terminal, and workpiece is with the negative terminal, and this is DC power source. So this is called a straight polarity. A straight polarity. And this is called reverse polarity. Various times question is going to be asked, in case of reverse polarity, which is connected with the negative terminal? It will be the workpiece. Electrode is connected with the positive terminal. In case of straight polarity, workpiece is connected with the positive terminal and electrode is connected with the negative terminal. Now see my dear friends, here whatever heat is generated, this type arc is coming. So here 1/3 heat is generated, 1/3. At the workpiece 2/3 heat is generated. Total amount of heat 2/3 is on the workpiece and 1/3 over the electrode. But here in that case we can say whatever heat is generated there 2/3, because in that case the negative ions goes on the electrode and the negative ions goes there, more kinetic energy, so more heat generated. So 2/3 of heat is generated over the electrode and 1/3 heat is generated over the workpiece. Now one thing I want to be asked, tell me in which case you would get the more consumption of the electrode, in the case of that one or that one, in which case you will get the more consumption of the electrode. So we can say, since more heat is generated in the reverse polarity over the electrode, so obviously they will melt faster, right? So my dear friends, you have to be just keep in mind, deposition rate will be high. What will be? Deposition rate will be high. But here comparatively if you talk, since less heat is generated, so here deposition rate is what? Deposition rate is what, my dear friends? Deposition rate is comparatively low, right? These two things. Third is what? AC power source, that I will discuss later on. Now one more concept I have to discuss, then I will come on the question part. This is called arc blow. This is called is what, my dear friends? Arc blow. What is arc blow? Do you know anybody? Arc blow. This is another question, important question going to be asked various times in the exam. Arc blow. What is happening, my dear friends? Arc blow. Suppose this is your workpiece. This is your workpiece. This is your electron. This is your electron, like that. Okay. Negative. Suppose that is your positive terminal. Obviously, this is the DC power source. Now, what is happening? The arc is deflected from their intended path. You will want, is an arc should come like that. Arc should come like that. But actually, what is happening? Arc is deflected. How deflected, sir? Arc is deflected like that, sir. And this is called arc blow. The deviation of the arc from their intended path is called arc blow. The deviation of the arc from their intended path is called arc blow. Now the question is that, sir, why arc blow is happening, sir? What is the cause behind the arc blow? Yes, right. Now come to that point. Why the arc blow is coming? Suppose, my dear friends, this is the workpiece and this is your, electrode. So current is passing now, and in the class 9th or 10th, you might have been taught that when electricity is passed in their perpendicular direction, one magnetic field is generated, right? If the current is passing through like that, so what is happening? In that direction, what is happening? Magnetic field is generated. So sir, here current is passing like that. So what is happening, sir? Sir, one magnetic lines of force is developed like that. Because electricity current is passing like that, so magnetic lines of force is going to be developed. And you know, my dear friends, what is happening, especially if you are going to weld at the end. Suppose you are going to be welded here at the end of the workpiece. This is the end of the workpiece, and obviously, let's assume like that. So, what is happening? You can say here more magnetic lines of force is this side. Due to that, the arc is happening like that. So the arc below is mainly due to unbalanced magnetic lines of forces. It is mainly due to unbalanced magnetic lines of forces. And once it is happening like that, my dear friends, can you get proper welding? No, sir, I cannot get proper, because your target is more heat should come there, but it is not coming here. It is going to be like that, so it will not give a proper welding. I will see the one diagram to you, arc below there. Here I have one diagram. See, this is here. You can see here, this is called spatter loss. If arc flow is happening, what is happening? Molten material goes in the unwelded part. This is happening arc flow, and the molten material goes on the unwelded part. Due to that, this loss is happening, and this is called is what? Spatter loss. And spatter loss is not a good thing. So what is happening here? We can say because of that whatever molten material is there, this come in the unwelded part. So this is called is arc flow. Now this is good or bad? Obviously arc flow is bad thing. First thing you have to remember, sir, arc flow is what? It is the deviation of the arc from the intended path. What is the cause of arc flow? Sir, magnetic, or you can say the due to the unbalanced magnetic lines of forces. Yeah, if you are going to weld at the center, if you are going to weld at the exact center, then we can say, sir, the arc flow will be the least, but not it will be zero. Now the question again you can ask, sir, if arc flow is same here, it is not a good thing, then how we can control the arc flow? How we can control the arc flow? Anybody can tell me? First thing, tell me, if you have to reduce the arc flow, what should be power source? It should be high or less? You have to be think and you have to be answer. If high power source will be there, my dear friends, then what is happening? Huge amount of magnetic lines of force will develop. If huge amount of magnetic lines of force develop, they will what? They will deviate more. If they will deviate more, the arc flow will be severe. So if you want to reduce the arc flow, the first step, you have to use the low power source. You have to use what? Low power source. That is the first thing by which you can reduce the arc flow. What another you can do, my dear friends? What another you can do? Suppose this is called arc length, my dear friends. This gap is called arc length. This gap is called arc length. Now, if you want to reduce the arc flow, you have to be answer, what should be arc length? High or low? Tell me, what should be arc length? High or low? What should be high or low? Arc length should be high or low? Obviously, we can say, you can think and we can say, suppose that this is arc length. This is, let's assume, arc length. So they are going to be deflected much more. But if I am going to reduce the length, sir, if electrode is like that, sir, so length is reduced, sir, so like that, it is like that. So another thing that you can say, by reducing arc length, we can reduce the arc flow phenomena. That is the second thing. Good. Now, third thing, what we can do, later on I will taught one concept. This is called coating of electrode. This is your electrode, right? This is your electrode. Our electrode, I am going to use some material called coating, right? This is like that. This is called coating. This is called coated material. Now, due to this coating, what is happening? If there is no coating, my dear friend, suppose if there is no coating, then what is happening? They will start from that end itself, and it is happening like that. But due to the coating, we can see little bit they are going to be protect there. They are going to be protect there. So what is happening? By the coating of electrode, we can reduce the arc flow. Right, sir. You can reduce the arc flow by coated of electrode. Yeah. Now, what another thing we can do? One is called welding speed. What? Welding speed. So see, what should be welding speed? It should be high or it should be low. It should be high or it should be low. What do you think? If it will be faster, the deviation will be more. If it is going slowly, the deviation little bit we can control. Little bit, not much more. So we can say by reduce the welding speed. What is welding speed? Because you have to weld throughout now. So you will give one velocity. Yeah. This is called VW. This is called welding velocity. It should be less. That fourth way, what we can do the fifth things. What we can do the fifth thing what we can do. Suppose my dear friends, here we can see, sir, this is our electrode and workpiece. This is our workpiece, and this is our electrode. They are connected like that. Okay, negative and positive DC power source. Now, in case of negative, you can say what is there is a like that magnetic lines of forces. This is magnetic lines of forces. Positive terminal, there is also magnetic lines of forces in the wire, but which is negative terminal, so direction will be the opposite. It is like that, it will be like that. What we can do? Just take that wire and wrap that wire over the workpiece. Wrap that electric wire which is connected to the electrode, just wrapped over that. If you are going to be wrapped that one here, if you are going to be wrap that one, so what is happening? Their magnetic lines of force in the opposite direction, so they can reduce the arc flow. Even if you have seen in your bike, if you are going to do the arc welding, we can see over the workpiece they are going to be wrapped few turns of the wire over the workpiece so that the arc flow will get minimized. Arc flow will get minimized. So by that 5 ways, let or much more thing is there. Another 2 way by which we can reduce that. Earthing you can do the earthing. Another thing that we can do, suppose this is the workpiece, you are going to be welded. Suppose this is the workpiece, you are going to be welded. So what is happening? So sir, obviously it is electrode, so it will be connected with the some terminal, it will be like that, positive, negative. So there is a like that. Okay, there is a like that magnetic lines of forces. Now what we can do? Place some material. Suppose this is the material I have to be weld. Current is passing, and I have placed the plate like that. So what is happening? The magnetic lines of force will pass from my hand also. This is like that, no? This is like that. If my hand was not there, this was look like that. But if my hand is there, it is something like that. So my hand will also reduces the intensity of magnetic lines of forces. So by you can say placing the plate around the workpiece, you can reduce the phenomena of arc flow. So that is the seventh way by which you can reduce the arc flow. Now that was the some basics. Okay, and due to the arc flow, one severe defect is going to be seen. This is called is what, my dear friends? This is called is spatter loss. This is called one of the welding defect, because if this is coming like that, so what is happening? The molten material which is there, they are going to be splitting like that. This is going to be splitting like that. So it is not going to use for the welding. So it is welding defect, right? Sir, till now whatever you have discussed, you have just reduced the arc flow, sir. Sir, you haven't met the zero, sir. How I can make the arc flow zero? Right. Whatever approach I have did till now, I have just reduced the arc flow, not become it zero. Now suppose you are going to use the AC power source. My dear friends, this is workpiece, right? This is workpiece. This is your electrode. Now this time power source is AC. AC power source. You know what is AC? AC means alternating current. AC means what? Alternating current. What the meaning of alternate? Alternate means, my dear friends, their polarity will change. Like in the DC. In the DC, once this is a state, suppose once it is positive terminal, workpiece is positive, it will be always positive. Here it is electrode is negative, it will always negative. This is DC because their polarity is not changed. But if you talk about AC, so alternating current, the polarity is going to be changed. When in a, suppose I am telling you AC source frequency is 50 hertz, AC source frequency is 50 hertz, which is going to use in your household. 50 hertz. What is the meaning of that? Means in 1 second, 50 times polarity will change. In 1 second, how many times? 50 times polarity will change. Polarity will change. That is the meaning of 50 hertz. So what is happening, my dear friends? This is arc. When it will be like that, another instant it will be like that, another instant it will be like that, again it will be like that, another instant it will be something like that. So what is happening, my dear friends? Well, in 1 second that is happening 50 times. So what is the net magnetic lines of forces? When it will be positive, it will be something like that. Instantly it become negative, it will be like that. Again it become positive, it will be like that. Again it will become negative, it will be like that. So what is happening? Net magnetic lines of forces. We can say, yes sir, net magnetic lines of forces become zero. And you know, my dear friends, arc blow because of magnetic lines of forces. Arc flow is what? Because of magnetic lines of forces. So here magnetic lines force becomes zero now. So how we can get the arc flow? So you can say in the AC power source, arc flow will be zero. But in the DC power source, we can always observe the arc flow. The thing is that it will be less or more. Arc flow will be less or more, but it will not be zero. If you have to make the zero, you have to use the what? You have to be use the positive AC power source. That was the thing that you have to be remember. Now come to the some question part, then I will come. Whatever I have taught till now, this I am going to take question. Give the answer of that one. In DC polarity, reverse polarity or welding. In DC reverse polarity or welding, tell me what will be answer of that one? Reverse polarity, what is happening? Answer fast, my dear friends. Everyone have to be answer. Yeah, everyone have to be answer, my dear friends, so that we will get engaged, right? See there. This was now here we can see here. This is state polarity, right? Electrode is connected with the negative terminal. Workpiece is connected with the positive terminal. अरे पागल आदमी है क्या ये? Okay. If you see there in the reverse polarity, what is happening here? Electrode is connected with the positive terminal and workpiece is connected with the negative terminal. Okay. So that was the question has been asked once. Now I will come on that also. What will be answer of that one? That is another question. What will be answer of that one? Anybody can tell me? I will expect answer from everyone. And in the same way, I'll teach all that. Okay, so don't worry. All concept I will discuss in the same way. Yes, I will play the video also. I will play the video as required. Later, I will discuss the. I will play the video also. So I think everyone have given the right answer. Yeah, right. A for apple is the right answer. Everyone is given right. Okay. Take this. What is welding spatter is? What is this? A for apple, everyone. Welding defect, right? One more thing, my dear friends. If the high power source will be Now tell me, if high power source, what will be at high power source, at high, what is happening? At high power source, a spatter loss. What will be a spatter loss? What will be a spatter loss? Option A, more. Option B, less. Option C, same. Option D, none. Anybody can tell me? Anybody can tell me? What will be arc below? Right. You are getting right. If high power source will be na, then you know the arc below will be high. Arc below will be high. Once arc below will be high, it will become said here more of the molten material goes towards the unwelded sides, and it will one types of defect. Here we can see now. See my dear friends, that you have to be welded like that, but here we can see this all are this note, it is wastage na, it is this all are wasted na, so this is called a spatter loss, or we can say the welding spatter, right? That's good. Come to the next question. Yeah. Okay, answer that question. Then I will discuss the concept that one. In arc welding process, the current value is decided by thickness of plate, length at weld portion, voltage across arc, speed at travel. What will be answer of that question, my dear friends? What will be answer of that one? Everyone. What will be answer? Waiting for more answer. Everyone have to be answer, my dear friends. Thickness of plates, length of the weld. Okay, Manoj, Susil, Nega Venkat, Tejaswi. Well, so the correct answer is what, my dear friends? A for apple is the right answer. See, if the thickness of plate will be more, no, my dear friends, if the thickness of the plate is more, so high deposition will be required, right? So you have to be, this is negative, this is positive, so you have to be use the high power source. So it is going to be depend what the thickness you have to be used, because you know the heat is generated is what, my dear friends? I square RT now. I square RT heat is generated, right? Suppose if thickness is less, if thickness is less, and you are going to use the high power source, high current is there, so huge amount of heat will generated. So rather welding, what they will do? They will do the cutting operation. In the metal cutting, I will teach you about that. When the high heat is generated, what is happening? They do the cutting action rather than welding. Okay, so if the thickness is less, your target should be, the eye should be less, so that less amount of heat will generate, just it is welded, not going to be cut. So the correct answer is what, my dear friends? A for apple is the right answer. This is going to be decided by the thickness of plate, right? Everyone, people who have given the Chennai, Prajwal, Sharma ji, clear? Clear? Tell me, you guys have given the wrong answer. Okay, fine. Now I am going to discuss another thing, then I will come. See, that is the another question, my dear friends. In thermic welding, heat is generated from a chemical reaction involving finely divided aluminum and iron oxide, combustion of gases, electric arc, none of the above. Now we can ask, sir, what is thermic welding? That is the first question that we can ask. Then I will move to the answer. Thermite welding is what, my dear friends? Suppose anytime, okay, what answer? A for apple, yeah. What about others? Okay, see what is thermite welding? Whenever, especially this welding is going to use in the welding of the railway track. In the welding of the what, my dear friends? Railway track, this is mostly going to be used. Okay, tomorrow I will see their video. Don't worry. Today, actually, I have forget to coming their PDF. What we can say drive. That's why. But tomorrow in the next session, first of all, I will see the video of the thermit welding, how it works. Yeah, yeah. Any doubt anyone have? Guys, if you are talking to me, then you can unmute. Otherwise, you can mute yourself. Yeah, tell me. Yeah, mute na. I have option to mute all. Who is there? Who is? Please ask them to mute. I don't know. One is speaking. Tarun. Tarun, unmute yourself. Okay. Right. So my dear friends, tomorrow I will see their video how thermite welding works, right? I forget to take their PDF today or their file today. So tomorrow I will play that video. Thermite welding is a chemical reaction involving finely divided aluminum and iron oxide. What is happening? Very simple process it is. This is called on-site process. You will have one cylinder, right? You will have one cylinder. Okay, this is your cylinder in which what is happening, you will have iron oxide in fine, iron oxide in the finely form. This is iron oxide. This is what? Iron oxide, because that material, railway track is iron, so it will be the iron oxide. There will be in the powder form of aluminum. This is powder form of aluminum or fine form of aluminum, right? This is aluminum and this is your iron oxide. This is kept in one cylinder, right? Take the cylinder, goes to the welding site. Take that cylinder, goes to the welding site. Suppose this is your railway track, which you have to be welded. This is broken down, which you have to be welded, right? Here you have to be welded. So come to that, to the site, and after that what you have to do, you use the magnesium rod. You just put the magnesium rod. What? Magnesium rod at the sites, then you have to use the magnesium rod. Once you give the magnesium rod, now my dear friends, within 20 to 30 second, 20 to 30 second, here reaction started and the heat generated approximate 2700 degrees Celsius. That data sometimes 750, 2750 is given, sometimes 2700 is given in the different book, but we can assume 2700 degrees Celsius. Now in that form what is happening? There is a huge amount of heat is generated, and due to that huge amount of heat, what is happening? They start melting, and once that melted, just from there, come and put that molten metal there. Here will be something which protect to flow the molten metal in all the side, and this molten metal will come and fill the cavity, and your your welding takes place. So that thing you have to be keep in mind. Tomorrow I will play the video, it will be much more clarity, right? So that is called thermite welding. Now another thing we can say, in thermite welding what is happening, three part will be the iron oxide and one part will be the aluminum. One part we can say, here even you can see the three part of the iron oxide, one part will be the aluminum. That question is also going to be asked several times. Few times the question is going to be asked is what, my dear friends? To start the reaction, which rod is going to be used? So it will be the magnesium rod. This work like a, what we can say, a starting of the reaction. So that if you are not going to use the magnesium rod, no reaction is takes place. So once you add it, will get. So chemical reaction involving finely divided aluminum and iron oxide is responsible for the generation of heat in case of thermite arc welding generally used. Here we can say Al this, and after that this is happening 9, and this is called exothermic reaction because heat is generated, and ratio of this is 1:3. Aluminum and oxide will be 1:3. Thermite welding is a form of resistance welding, gas welding, a fusion welding, or arc welding. What will be the answer? It is gas, resistance, arc. Obviously we can say, sir, this will not arc because no arc is generated there. It is not a arc welding. Sir, it is not a gas welding. I will teach you what is gas welding now. In the today class, I will teach you, or maybe in the tomorrow session. Sir, it is not a resistance welding, sir. It is not a resistance. So what is this? Sir, fusion is coming, na, sir. Just now I have told, na, reaction started and it here melted and their fusion is coming like that. So it comes under the what? Fusion welding. So my dear friends, you guys have given the right answer. C for Chennai is the right answer. That's good. Tomorrow I will play the video, don't worry. The ratio of aluminum and iron oxide used in the thermite welding. What will be answer of that? The ratio of aluminum and iron oxide used in the thermite welding. A for apple, A for apple, A for apple. Yeah, 1:3. Various times that question has been asked in different exams. Even in the BL also that one is asked. So okay, try to remember that one. One issue, obviously, na, yeah. Since you have to weld the iron, so more content should be of iron, na. That's why iron quantity will be high. Even that way we can also think. So A for apple is the right answer. Okay, that you have did. Which of the following welding process use consumable electrode? TIG, MIG, thermite welding or gas welding? So before moving to that question, I will give the concept of TIG and MIG. Then I will move on that. And thermite welding we have already discussed. Gas welding I will discuss in the another question. So before answer that question, I have to be discussed very details TIG and MIG because this is a very frequently concept has been asked in several exam, my dear friends. TIG, MIG, you might have read in your college day also. It is more important. So before answer that question, what I have to do? I have to be discussed these concepts in the little bit detail. Okay. So I think I have one diagram here. TIG, MIG, I have diagram. Here, my dear friends, we can say this is TIG, tungsten inert gas welding. This is MIG. MIG is what? Metal inert gas welding. This is called MIG. This is called TIG, tungsten inert gas welding. So here we can say everything is same here. Inert gas, here also inert gas, molten pool, here also molten pool, base metal, all that. Here machine feed wire rod, here fixed tungsten electrode. So contact tube, gas nozzle, arc, everything is there. See my dear friends, what is happening. I am going to discuss about the TIG and I want to make sure everything will be settled down in your mind. See, this is your workpiece. Just listen. Everything I will discuss. You will never forget. It's my promise. This is your electrode. Right. From their name itself indicate. Sir, from their name itself indicate it is the electrode of tungsten. This is what? Tungsten. And you know, my dear friends, in case of tungsten, what is happening? Tell me, in case of tungsten, what is happening? Tungsten have high melting point, right? So tungsten is not going to be consumed. That's why, yeah, what comment? Sir, please zoom the, okay, this you call light? You want to be tell this thing? Mr. Who is there? Dhanush, right? And yeah, I want to be tell sorry because sometimes I am not going to be pronounce your name correctly. Okay, so advance I want to be tell sorry for that. Huh? So see my dear, just listen step by step. Everything will be settled down in your mind. Just listen. So the first concept, sir, you know, tungsten inert gas welding, TIG, tungsten inert gas welding. Here I am going to use the one inert gas. That's why it is called inert gas welding. Here that also is a type of arc welding. First of all, what you have to do? You have to do the short circuit. Once you do the short circuit, after that just remove the contact and arc is generated. So that is the basic concept. You know my difference. Generally what is happening, sir, in this case, heat is generated both hand, na sir. Here positive ions goes, or here this is positive ions, or here negative ions come. Right, here negative ions come. But at the electrode also heat is generated. An electrode is made up of tungsten having melting temperature approximate 3500 degrees Celsius. Approximate, it could be little bit high and more, because in the different books 3050, 3450, 3400. So let's assume 3500 degrees Celsius. So what is happening, sir? In that case, heat is generated on the electrode, but electrode is not consumed. So temperature of the electrode rises. And my dear friends, if the temperature rises, what will be the conductivity? Obviously, sir, by increasing temperature, conductivity decreases. So, sir, as their temperature increases, the conductivity decreases. Once the conductivity decreases, can it can it good or bad? If the temperature rises, conductivity decreases. Once conductivity decreases, proper amount of heat is not going to be takes place there. So it will be loss of energy, na sir. So it will be loss of energy, sir. It will be loss of power, sir. So that's why I have to use here what, my dear friends? I have to use here water jacket. I have to use there what? This is water jacket. And this is water jacket I am going to use, so that when the temperature of that tungsten kept within the range, so that there should not a proper huge amount of loss it takes place. It will take the water temperature from the tungsten, it will be less and proper it will work. Now one question I will ask to you guys, then I will come. Tell me, if I will ask, is it good to use the reverse polarity in TIG? Yes or no? Yes or no? Tell me, is it good to use the reverse polarity in TIG? Yes or no?
No.
Bilkul right. You are absolutely right. No. Why? Sir, in the reverse polarity, what is happening? Huge amount of heat is generated on the electrode, no, sir? In the reverse polarity, this will be negative, this will be positive. So, huge amount of heat is generated on those end where negative ions will go. So huge amount of heat generated on the electrodes, sir, and it will be very bad thing. That's why, my dear friends, generally in the TIG, I am going to prefer the straight polarity, not the reverse polarity. So that third thing you have to be always keep in mind. Now, another thing I want to ask to you guys, I am not going to answer. Okay, you will answer yourself. Now tell me, the power source that I am going to be used there, it should be high or it should be less? It should be high or it should be less? Tell me everyone, my dear friends, high or less power source? High or less? Now see, just listen. If you are going to use the high power source, let's assume, okay, no problem, you are going to use the high power source. Let's assume. If you use the high power source, what is happening? What is happening, sir? What is happening? Sir, if high power source I am going to be used, huge amount of heat is generated at the electrode. If the huge amount of heat is generated at the electrode, sir, so sir, that is good or bad? Again bad, sir. Because my target is not to generate a huge amount of heat on the electrode, because it is a tungsten. Temperature rises, conductivity decreases. This will be the loss of power. That's why, my dear friends, always keep in mind, in case of TIG, I am going to use the low power source. I am going to use the what? Low power source. Always in case of TIG, I am going to use the low power source, not the high, because high power source will be there, high heat is generated, and there one third of it, suppose 100 joule heat is generated, so one third will be here, so 33 joule. If you use the high power source, it will be 300. So here will be 100. So more heat is generated on the electrode, which is not good. That's why always keep in mind, TIG uses for low power source. Okay, getting, sir. Now another concept that I want to discuss. Now my dear friends, tell me, if the low power sources is there, is it weld for a thinner or thicker material? Thinner or thicker? Thinner or thicker? What do you think? Thinner or thicker? Yeah, thinner. Because, sir, because less amount, current is coming, na, sir. So less amount of heat is generated. That's why always keep in mind, TIG used for thin, especially used for TIG used for sheet. What, my dear friends? It is used for sheet. What? You have two terms. One is sheet, one is plate. Sheet and another one is plate. You know? So what is sheet? If the thickness is less than 5 mm, if thickness is less than 5 mm, then it is called sheet. If thickness is more than 5 mm, then it is called plate. Always one thing you have to be keep in mind, generally TIG prefer for the sheet. TIG is prefer for the sheet, not for the plate. बिल्कुल RK, you are बिल्कुल right. Okay, till now everything is clear. Good. Now another question I will ask. Okay, sir, that's fine, sir. Why I am going to use the here one inert gas. Here you can see in the diagram. Here we can see in the diagram. I am going to use the inert gas. Where molten pool inert gas cylinder is there, sir. Why I am going to use the inert gas cylinder? Yeah, that is another good things that you have to be keep in mind. As I told you, my dear friends, as I told you, in case of TIG, low power source is used. Yeah, right, sir. You have just told in TIG, low power source is used. What you comment? Yeah, low power source is used. Right. Okay, tell me one thing, my dear friends. For generation of arc, this is workpiece. This is your electrode. Right. So once do the short circuit, the heat is generated. Since power source is less, so heat generation will be less. Heat generation will be less. And my dear friends, it might be possible the heat generated, it is not equal to the bonding energy of the positive ions, because we have using the low power source. Because of low power source, it might be, I am not telling, it might be possible that heat generated is not sufficient to the bonding energy. If it is less than the bonding energy, once you disengage the contact, might be possible arc will not move, arc will not generate. Why? Because in between that air is there, no sir, air particle is there, no sir, it will oppose. And since heat generated is less, obviously they cannot start moving of the ions, no arc will generate. That's why, my dear friends, I am going to use the inert gases. That's why I am going to use the inert gases. Inert gas come and remove all that. And you know, my dear friends, inert gas is not taking any participation in the reaction. So it will not allow, it will not, disturb the movement of ions. It will not disturb the movement of ions. That's why you are going to use the inert gas. Inert gas comes and remove the air from there, and once the air is removed, after that what is happening, the positive ions start moving to the tungsten, and from tungsten it is coming to the negative ions. So that's why, since the thickness is less, power source is less, so remove the air. I am going to use the what, my dear friends? Yeah, Utkarsh, remove air from between. Bilkul right, Manoj. R can also act as a, yeah, bilkul. It is work right. So that all about the TIG. Everything. Okay. Now we can see, oh, lamba comment. Thin workpiece, tungsten electrode. Right. Right, Chandan. Right, you are. Everyone is right. Okay. So till now everything is clear now. Okay. One more thing, my dear friends, especially material which is highly, we can see the oxidative, the material which can highly oxidative in the nature, or highly we can say the reactive. For that case also you are going to be use the TIG. Especially if you talk about the aluminum, tungsten, not tungsten, titanium. In that case you are going to prefer for the TIG. Aluminum, or we can say the titanium, in all that case you are going to be in case of sheet form. So here we can say, sir, it is not a consumable. That's why it is called non-consumable electrode, because it is not going to melt it down. So what will be answer in that case, my dear friends? So what was the question? Question was which of the following welding process uses, okay, consumable electrode. So TIG uses non-consumable. It is non-consumable. Now think about MIG. MIG is called metal inert gas. MIG is called is what, my dear friends? Metal inert gas. here we can say, here we can say, here we can say the, okay, here we can say machine fed wire rod. In that case, what is happening in case of MIG, you are going to use the consumable electrode like that. See, okay, I haven't space. Okay, so in case of TIG, I'm coming there. Okay, in case of MIG, if we talk about me, what is happening? This is your workpiece, right? This is your electrode, okay, and this is your let's assume power source. This is positive terminal and this is negative terminal like that. So it is what? Reverse polarity. In that case, what is happening? We can even see the more heat is generated over the electrode. More heat is generated over the electrode. It is always preferred with the, generally MIG preferred with the reverse polarity. That is the, so due to the reverse polarity, what is happening? Huge amount of heat is going to be generated over the electrode, Q3 we can say more precise. So it is just you can say the melted and coming down. So it is going to be consumed. That's why it is called consumable electrode. Now again we can ask, sir, if you talk about MIG, in case of TIG, you can use 6 mm, sorry 5 mm. Thickness in case of MIG should be less than 5 mm in TIG. But in case of MIG, thickness should be less than 30 mm, more than 5 mm or less than 30 mm. Why? Because you know, my dear friends, if thickness will be more than 30 mm, then again you need more power source. If the more power source, again the problem will be the arc blow. Again the problem will be the arc blow. And that is not a good thing. A spatter loss can be. That's why MIG up to the 30 mm. If you have to weld more than 30 mm, then one process is called SAW. I will discuss. This is called submerged arc welding. If you have seen the cylinder, LPG cylinder in your home, that is welded by the SAW, submerged arc welding. I will see that. I will play the video. Don't worry. So this is MIG. MIG up to the 30 mm we can do. After that, a spatter loss starting, which is not a good things. And it is generally it is preferred with the reverse polarity. So when deposition rate will be high. Now see, my dear friends, I am going to be control here. I am going to use electrode in the form of wire. In the form of wire. Why? These two types. One is called rod. Electrode happening in the two types. In terms of rod and in case in terms like a wire. If you are going to use the rod now, so once that consume it, once they consume now, then to using another electrode, you have to be stop the process. So it is not a good. That's why I am going to use the wire electrode. Here we can say wire, continuously it is going to be consuming, and one machine will be there, through dot it is coming. That's why it is called. Okay. One more thing, tell me, it is coated electrode or non-coated? Always keep in mind, that is another thing. In case of MIG, it is non-coated electrode. If you another arc welding, I will teach you, the coated electrode is going to be used. But here we can say bare electrode. Nothing I am going to be coated over the electrode. It is bare. So another most important, and mostly that question has been asked in MIG, which type of electrode is used, coated or bare? Obviously it will be the bare. I haven't made any coating, right? Okay. Rest thing I will discuss in the questions. Don't worry. So that was the question here. Here you can see the machine fed wire rod, wire, and a molten metal pool is happening in base metal, and we will get the shielding gas. This is the shielding gas which will remove the air, and shielding gas, argon or helium is going to be used. TAG, right? Okay. Come to the next question. I think that thing is clear. TIG welding. Oh, everyone can answer. No. What will be answer for that? Everyone can answer that one. I will, okay, don't worry, as I told you now, tomorrow I will play, before I will come start the session and I will play all that video. Sorry for today, I haven't came with the video, but yes, in the next session, first of all, I will play all that video, okay, whatever I am going to discuss. Then I will start the next session. Don't worry. All option no, my dear friends. TIG, tungsten inert gas is preferred. No, you are generally preferred in case of aluminum according to given option. Still na yaar. Generally arc में ना still will be very arc flow takes place. Okay, so I'm not going to be used. Right? Silver is not. So correct answer will be for Bombay. And good thing is that everyone have given the right answer. Yeah, what will be answer? The major difficulty during the welding of aluminum is due to its high tendency of oxidation, high thermal conductivity, low melting point, low density. Everyone have to
Okay.
be answer. What will be waiting for more answer? I am waiting for more answer, my dear friends. Yeah, 80, I think 90% of the guys had given A for apple, A for apple, and yeah, this is the right answer. Just now, someone is coming with a low melting point. That is not a factor, my dear friends, because of low melting point. That is not a major things. The major things is that high tendency of oxidation. What is happening? Once you welded, the oxidation is takes place. Due to oxidation, one layer is formed which is in the brittle in the nature, which is not good. So that is the one of the major difficulties in the welding. Okay, suppose in the option A is not there, and then the low melting point you can go through that. But if high oxidation option is there, then you have to be go through one A only, not C for Chennai, Mr. RK, right? Low melting point. Okay. So always keep in mind tendency, just even in the college day, yeah, you have seen. Have you did that experiment? Aluminium, very frequent time you have seen one layer is going to be formed there, aluminium oxide, and aluminium oxide is very brittle. Oxide of anything in the brittle. Oxide of anything becomes brittle, and that is not the good. So due to that, you are going to be. This is the one of the major difficulties in the aluminium. Fine. Everyone can answer that one. Satinder, just after class, I will share that PDF. Just once the class is over, within 1 minute, I will share that PDF in the group, and same PDF will be uploaded on the panel also, so that we can access any times. What about others? What you have given the answer? Right. Okay. Everyone have given the right answer. More encountered in the DC welding. Edges, na, it will be more severe, yeah. Here we can see, na, like that. Yeah, especially at the edges, it will be the more severe. In contact, this is the right answer. What is the type of shielding gas for GTAW, gas tungsten arc welding, used for carbon steel only? Which type of that carbon steel? Leave that. That is only things. Which type of inert gas you are going to be used? So I have told you what will be answer of that one. Oxygen, argon, nitrogen, or hydrogen. What will be answer? B for Bombay now. Everyone now. B for BL. Right. Argon. Argon or helium is going to be used. Six inert gas are there. Helium, neon, argon, krypton, xenon, radon. Various property. Mr. Amol, various property here. Various property have to be choose. Which thing, like if anything is very highly magnetic in the nature. If any material which is highly magnetic in the nature. Can you use the arc welding? No sir, because in the arc welding magnetic lines of force is developed and already material is highly magnetic. So magnetic lines of force will be very safe here. So in that case you cannot use the arc welding. Right, in that way various property you have to be see. Which is highly magnetic, never you can use the arc welding. You can use another welding, you have lot of friction welding, gas welding you can use for that. Submerged arc welding is okay. Now you can ask submerged arc welding. What is submerged arc, sir? What is submerged arc? See there. I have come with the diagram. See this we can see here. Arc is submerged. Here we can also see. I will play the video. Don't worry. As I promised now, tomorrow first of all I will play the video of all that. As I told you. So don't worry. Here we can see this is happening even in the cylinder. LPG cylinder is going to be welded by the what? SAW, submerged arc. Why it is called submerged, sir? Why it is called submerged? Because we can see arc is submerged in the granulated flux. This is called granulated flux. Here, whatever flux is what? Flux is the material which here we can going to be used so that it is going to make a one of the layer which will protect, and there will be the uniform cooling within the material, and that is the good thing. Not flux has a various function they have to perform. Flux have various functions they have to be performed. Out of which one function is that it will, you can say here one layer is going to be formed. Due to that layer, what is happening? The uniform cooling takes place within the material. And that is a good thing. Uniform property I can achieve. If the cooling is not uniform, it will be distorted and material could be the brittle. Right. So the various property. So here we can say the flux is granulated flux. Granulated means in the powder form. That question is also going to be asked. In which arc welding granulated or powdered form of flux is used? The answer will be SAW, submerged arc welding. And you know my dear friends, in case of submerged arc welding, since arc is submerged, so no problem by arc flow. Arc flow will take place is when if the arc flow will take place, it is happening something like that. No, then arc flow is happening. But suppose if arc is inside the flux, this is flux and arc is inside. So how they can deviate? Because everyone is arc now, so it cannot deviate. That's why my dear friends, in the whenever you are going to use the high power source or you have to weld the thicker material like up to the 90 mm, in such case I am going to use the submerged arc welding. There is no any spatter loss, no any problem. That is the good. So any material can be welded by SAW. Yes, you can, any types of material we can weld. But the question is that, sir, I have to be need the selection of the proper flux. One thing I will teach you in the next session. Little bit I am going to introduce right now about that. That is your electrode, my dear friends, because you have another session after some time. That's why. So this is called electrode. Here it is coated. Here it is a bare electrode. Now I am going to use the material like that over the electrode. Okay, like that. So this is called coated. This is called coating material. This is called coating material. Coating material. Then this is also known as flux. Coating material is also known as what, my dear friends? This is also known as flux. Now the coating material have several functions. First thing, always keep in mind the material which is going to be used for the coating, density of coating material, density of coating always should be less than density of base material. Always, 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 and always. Why, sir? Why this is necessary? Because my dear friends, once another thing, second thing, always keep in mind the melting temperature of you can say the coated material melting. मैं पूरा लिख देता हूं, melting temperature of coated material always should be higher than melting temperature of base metal. Melting temperature of base metal. Always. So that's why, suppose, that's why we can see it is here. Electrode has been melted, but it will melted once the electrode is completed, then it will melt. So my dear friend, these two things must be the property of the coating material. One, density should be less. Another, their melting temperature should be less than that of the parent material. Now what is happening, my dear friends? Once they melted, their molten pool is formed now. There, this is coming, right? So here molten takes place, and along that what is happening? Coating material also comes. If coating material comes and it is lighter in the weight, or lighter in the weight, so what is happening? This will go inside the pool, inside the molten pool, and whatever impurities are there, they will take out and come on the surface. So here, where is, I have seen the diagram now. Okay, where is MIG? It was here. We can see now this type of flux is formed now. They come down and take in the impurities, and with that comes over the surface, and they will form a protective layer. Due to that, it is a good thing, proper cooling or uniform cooling takes place. That is one of the advantage. And obviously if there is any unwanted material, so it could be the welding defect. So by using that, that defect is also going to be controlled, right sir? Right. So that is the one other thing of the coated material. What another thing is going to be made? Sir, what it is float when the melt in the weld pool? Right, RK. So that it will start float. No, another thing, see, my difference, as this electrode is melted now, as this electrode is melted, we can say the arc length changes now. This is called arc length. As this is melted, arc length increases, right? As the arc length increases, might be possible that due to the higher arc length, the arc will distinguish, right? If this is increasing, might be possible that arc will distinguish. Once the arc will distinguish, how I can do the weld? So another work of the coated material to maintain the arc within a certain limit. If the length increases, still they can protect the distinguishing of arc. So that is the one of the, you can say, the major advantage of the coated material. They are allowing the arc maintain even within a certain limit. So that is their advantage. So that is the 3 or 4 things. Another thing is that if there is a coating is there, so arc will be also less. So that all are the advantage of the coating electrode. So what was the question? Submerged arc welding, a process uses mixture of iron oxide. What will be answer of that one now? Still maintaining the hot molten metal pool between the plates, a process which is augmented under the blanket of flux, all of the above. What will be answer of that question now? Answer. What will be answer of that question? Blanket of flux, right? No, that no aluminum, maintaining hot molten metal pool between plate, no. Chilling, a process which maintain blanket of the flux, right? C for chilling is the right answer. And good thing is that most of you have given the what, my dear friends, right answer. Okay, so here you can say tomorrow I will play that video. What question is left now? How many question is left? Okay, that tomorrow I will discuss. Don't worry. Diffusion welding, all that tomorrow I will discuss. What the question is that? Material used for coating of electrode is called is what? Protective layer, slag or flux. What it is called? Tell me everyone. What it is called? Flux, right? Everyone, na? So D for Delhi is the right answer. This is material is called is what? Flux. And yeah, good thing is that answer everyone, na yaar. So D for Delhi is the right answer. Okay, that all question. So don't worry, whatever left tomorrow I will discuss and we'll move in the same way. Now, my dear friends, any have any asks, any doubt, please ask. Otherwise, we'll meet tomorrow. And what we have to be do? What your work? Once the class is completed, now I will share the PDF. Okay, go through yourself, try to solve the question again. And okay, one more thing. Whatever I am going to be done the question in the class. Beyond that, also, if you have any resources, practice more and more. And don't forget to attend the test series which will conducted very soon, or I think started, because once you get the come in the test series now you will get what you are going to make a mistakes. That is more important things. So don't be forget to attend that. Now, my dear friends, tomorrow I will come and I will play all the video. If anyone have any doubt, anything you can ask, you can ask. Otherwise, thank you for today. We'll meet tomorrow. Anyone have any doubt, we can ask. Tell me. If you know, tell me no, and now you can leave the session. Okay, my dear friends, thank you. Good night. We'll meet tomorrow at same time, 5:30 p.m. Thank you.